In the video before this one, we solved this system of equations right here. System of 3 equations and 3 unknowns. Just the long way, kind of without matrices, doing it this way. Now what I do is I always, when I cover matrices, this is what I do first, a problem something like this. Then I just show students how matrices are the same thing. It's just a shorthand notation. And it's the same thing, it's just the variables, x, y, and z, don't show up. We just have the coefficients and the right side of the equal sign. So we write down the matrix associated with this system of equations. 2, -1, -3, 3, 1, 1, 1, 2, and 3, 2, -1, 8. Now what I do is when I do this, I just show them how this is, it's the same thing as what we did here. I interchange row 1 and row 2. The idea is exactly the same. We want this entry to be a 1, so we can add multiples of that to these 2 entries to get them 0. So we interchange row 1 and row 2. 1, 1, 1, 2, 2, -1, -3, 3, 3, 2, -1, 8. And I should keep track here just like I am here. I'm neglecting that, but I would say this is just to keep track of the operations we're doing. So now we notice this matches this. 1, 1, 1, 2, 2, -1, -3, 3, and 3, 2, -1, 8. Now, the next step I'm going to do 2 steps at once, just to take less time. If I was teaching students, I would do each step at once. But our next step is we multiply row 1 by -2 and add it to row 2. So we multiply row 1 by -2 and add it to row 2. So row 2 is the only row changing. So we leave row 1 the same. And now we do our arithmetic. -2 plus 2 is 0. -2 plus 1 is -3. -2 and -3 is -5. -4 plus 3 gives us -1. The third row just stays the same. I'll do one step at a time here, just so it matches up with what we're doing over here. So we got this entry to be 0, now we want this entry to be 0. Well, to do that, we multiply row 1 by -3. So -3 row 1 added to row 3, that means row 3 is the only row changing. So write down rows 1 and 2. And now we do the arithmetic. -3 times 1 is -3 plus 3 is 0. -3 times 1 is -3 plus 2 is -1. Again, -3 plus -1 is -4. -3 times 2 is -6 plus 8 gives us 2. Now that matches this situation right here. Now we interchange row 2 and row 3 for the same reason we did before. We want this entry to be a 1 or -1, so we can multiply it by some number to get this entry to be 0. We could multiply this row by 1/3 or -1/3, but again, we're going to get fractions in there, which makes it harder to do the arithmetic in our head. So to avoid fractions, I'm going to interchange row 2 and row 3. So row 1 stays the same. Row 3 becomes row 2, and row 2 becomes row 3. Again, this matches this situation right here. Now we multiply row 2 by -3 and add that to row 3. Exactly what we're doing here. And what do we get? Well, row 3 is the only row changing, so we have 1, 1, 1, 2, 0, -1, -4, 2, 0, Negative 3 times negative 1 is 3, plus negative 3 is 0. Negative 3 times negative 4 is 12, plus negative 5 is 7. Negative 3 times 2 is negative 6, plus negative 1 is negative 7. This matches this system right here. And we use back substitution, which I'm not going to take the time to do that. But it's the same thing as we did up here. We just need to make sure students understand the first column corresponds to our x values. The second column corresponds to the y values, and the third column corresponds to the coefficients of the z values. In other words, this equation is really saying 7z equals minus 7, negative y minus 4z equals 2, and so forth.